Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the properties of ionic compounds. Let me start with the very first property, that's crystalline nature. Now, the crystalline nature stands for when the numerous cations and the anions arrange themselves in the 3D lattice, a solid is formed and that solid lattice is called crystal. Now let's hear it in detail. The ionic compounds are usually crystalline in nature, that is, they form this solid lattice. The constituent units in the ionic crystals are ions, that is, cations and the anions, but not the molecules. These ions are arranged together in a regular way in an ionic lattice. I have shown you this thing in the previous video in which I have drawn the lattice of the NaCl. Now, the force of attractions between the ions is non-directional. That is, the bond is formed in all the directions. That is, it extends in all directions. The ionic bonds are usually formed in all directions. There are not any directional constraints, so they are usually non-directional. Normally, each ion is surrounded by the fixed number of oppositely charged ions, and this number is known as coordination number. Now, for example, in case of NaCl, one Na positive ion is surrounded by 6 Cl negative ion, or we can say that one Na positive forms ionic bond with 6 Cl negative ions, and on the another hand, one Cl negative is surrounded by the 6 Na positive ions, that is, one Cl negative forms ionic bond with 6 Na positive ions. This is the lattice of NaCl. Let me prove you this thing. Now, let's assume we are talking about Cl negative and the Na positive. The white dots represent the Cl negative and the yellow dots represent the Na positive. Now let's talk about this Cl negative ion. Now let's count the ionic interactions found by this Cl negative by different Na positives. Now, I am counting the number of ionic bonds formed by this Cl negative with Na positive. Now that's the first ionic bond, the second ionic bond, the third ionic bond, the fourth ionic bond, the fifth ionic bond, and if we continue this lattice in an alternate fashion, we will get the sixth ionic bond or the sixth Na positive over here. So that means one Cl negative form ionic interactions with 6 Na positive. Now let's talk about the Na positive now. Let me delete this thing first. Now I'm talking about this Na positive. Hold on. Yeah, I'm talking about this Na positive now. Now let's count how many interactive forces the ionic bonds are formed by this Na positive with Cl negative. This is the first ionic bond with the first Cl negative, the second ionic bond with the second Cl negative, the third ionic bond with the third Cl negative, the fourth ionic bond with the fourth Cl negative, the fifth ionic bond with the fifth Cl negative, the sixth ionic bond with the sixth Cl negative. So here we got that one Na positive form 6 ionic bonds with the 6 Cl negative. So here we are having the coordination number of 6 in the crystal of, or in the lattice of, NaCl. We are having the coordination number of 6, that is, one Cl negative form 6 ionic bonds with 6 Na positive, and one Na positive forms 6 ionic bonds with the 6 Cl negative. So that's the coordination number of 6. Now let's talk about the next point, the melting and the boiling point. Melting and boiling point of the crystal or the ionic compound. Due to the strong electrostatic force of attractions, ions are held tightly in their position in the crystal lattice. So, the very high energy is needed to overcome the strong forces of attractions. Thus, the ionic compounds possess high melting and the boiling points. Now, let's talk about the hard and the brittle nature of the ionic compounds. Ionic compounds are hard due to the strong electrostatic forces of attractions, but they are brittle due to the movement of the layers of crystal on the other layers by the application of the external force. That's why they are brittle in nature. They break easily, but they are hard due to the strong electrostatic forces of attractions. Now let's talk about the fourth point, the solubility. Now let's talk about the solubility. Ionic compounds are fairly soluble in the polar solvents. What are the polar solvents? The solvents in which there is a charge separation, which we are going to discuss in the next lectures. So ionic compounds are soluble in polar solvent, but they are insoluble in non-polar solvents. And we will talk about the solubility of ionic compound in detail in the further lectures of hydration energy. Now, the last point, the electrical conductivity. Ionic compounds does not conduct electricity in the solid state because ions are not free to move. But ionic compounds can conduct electricity in molten or dissolved state because ions are free to move in the molten or the dissolved state. So that's all about today's lecture. These all are the properties of the ionic compound. I hope you all got today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.